Welcome back. We're going to take a look at problem 9. Find the charge Q of T on the capacitor and the current I of T in the given LRC series circuit. And we're also going to find the maximum charge. In this case, we're going to have L equals 5/6 henries, R equals 10 ohms, and the capacitance is 1/60 farads. And we're assuming that the impressed voltage is 1200 volts. We'll also assume that the initial charge is 0 coulombs and the initial current is 0 amps. Right, so we're gonna draw a little circuit here and then we're gonna record the inductance L. So we know that the voltage drop across the inductance is V sub L equal to L times I prime, and L is given to be 5/6. The voltage drop on the resistance is given by Ohm's law. So it's going to be equal to I times R. And in this case, the resistance is given to be 10. And the voltage drop on the capacitance is 1/C times Q, and C is given to be 1/60. So by Kirchhoff's law, we know that the impressed voltage is going to be equal to the sum of the voltage drops in the LRC series circuit. So we have V sub L plus V sub R plus V sub C is equal to E. And so V sub L is equal to L times I prime, and then I is equal to Q prime. So we can write that as L times Q double prime. And then we have I times R is the same thing as R times Q prime. And then V sub C is equal to 1/C times Q. So we're going to have a second order linear dE in Q. And let's put in the numbers that were given in the problem. So we're going to have 5/6 times Q double prime, because L is given to be 5/6. R is given to be 10. So we're going to have plus 10 times Q prime. And then C is given to be 1/60. So when we flip that over, we're just going to get 60Q. And then the impressed voltage is 1200 volts. And we're also given that the initial charge is 0 and the initial current is also 0. So let's start out by multiplying through to clear the fractions. So we'll multiply on this expression by 6/5. And after we do that, and we distribute the 6/5, we're going to get Q double prime plus 12 times Q prime plus 72Q is equal to 1,440. And so we can solve for Q sub C, the complementary function. So we're going to look at the auxiliary equation, which is going to be m squared plus 12m plus 72 equals 0. And we can solve this by completing the square. I'm going to subtract 72 from both sides. And so we're going to take half of 12, which is 6, and square it to get 36. And we'll add that to both sides. So we have m squared plus 12m plus 36 is equal to negative 36. And so what that gives me is m plus 6 quantity squared is equal to negative 36. Now rooting that, I'm going to have m plus 6 is equal to plus or minus 6i. And so subtracting 6, we get m is equal to negative 6 plus or minus 6i. And so what that tells me is that my complementary function is going, Q sub C is going to be equal to e to the minus 6t times the quantity C1 cosine of 6t plus C2 sine of 6t. So now we need to find the particular function. Now, since we have a constant over here, that's like our polynomial function, then the form of q sub p is just going to be a constant. And so what that means is that q sub p prime is 0 because the derivative of a constant is 0. And then differentiating 0 again, we get q sub p double prime is also 0. So we want to plug the expressions for q sub p prime, and q sub p double prime into this formula here and solve for the a, or the q sub p. So because these are both 0, we're just going to end up with 72 times q sub p is equal to 1,440. So dividing by 72, we see that q sub p is equal to 20. So let's put that back in. We know that the charge is going to be equal to q sub c plus q sub p. So what we end up with is the charge is equal to e to the minus 6t times the quantity c1 cosine of 6t plus c2 sine of 6t plus 20. So now what we need to do is we need to use these initial conditions to find the c1 and the c2. All right, so we know that q sub 0 equals 0. So plugging in the 0 for t, we're going to have e to the 0 times the quantity c1 times cosine of 0 plus c2 sine of 0 plus 20 equals 0. Well, we know that sine of 0 is 0 and cosine of 0 is 1. So this is just going to give me that c1 is equal to negative 20. Now, taking the derivative here, we're going to have to use the product rule. So we're going to see that q prime of t is going to be equal to minus 6 e to the minus 6t, differentiating this guy first, times the quantity c1 cosine of 6t plus c2 sine of 6t. And then we're going to get plus 6 e to the minus 6t. Now we take the derivative of inside the parentheses. And so we're going to have minus 6 c1 sine of 6t plus 6 c2 cosine of 6t. And of course, the derivative of the 20 is 0. All right, so now q prime of this should be a 0 here. Q prime of 0 is equal to 0. So I'm going to plug that in. So I'm going to have minus 6 times e to the 0 is minus 6. And I'm going to get c1 cosine of 0 is c1 times 1 plus c2 times sine of 0 is c2 times 0. So from the first part, I'm just going to have minus 6 times c1. From the second part, I'm going to get 6 e to the 0 is 1. And I'm going to have minus 6 c1 times 0 plus 6 plus 6 c2 times cosine of 0 is 1. And so that's going to give me minus 6c1 plus 6c2 is 0. And so that means c1 is equal to c2 is equal to negative 20. So what that means then is I have my q of t is equal to minus 20 e to the minus 6t times sine of 6t, and then minus 20 e to the minus 6t times cosine of 6t plus 20. And so we can factor out the minus 20 e to the minus 6t from both of these terms. So we have minus 20 e to the minus 6t. This is still equal to q of t. Minus 20 e to the minus 6t times the quantity sine of 6t plus cosine of 6t plus 20. So now let's find the derivative of the charge, which is the current. And so we're going to get minus 20 e to the minus 6t times e to the minus 6t times the sine of 6t plus cosine of 6t plus we're also going to get differentiating the second part. So we have minus 20 e to the minus 6t. And then differentiating the inside part, we're going to have 6 cosine of 6t minus 6 the sine of 6t. Now we can combine these. We can factor out a 6 and combine these. And when we combine, you're going to see that we end up with just minus 240 e to the minus 6t sine of 6t. Because factoring out a negative 6, and then adding them, we see that the cosine parts are going to cancel, and then we're going to get the sines are going to be adding once we factor out that negative 6 and add it. All right, so we have that. Now, if we want to find, so now we have the charge and the current, but we want to find the maximum value of the charge. So typically, what we want to do if we want to find extrema is we take the derivative and we set it equal to either 0 or undefined. In this case, we won't have any values of t where the derivative is undefined. So we want to look for values of t where the derivative is 0. So to find the extreme values of q of t, we're going to set q prime of t equal to 0. So if we have this expression equal to 0, well, we know that the minus 240 e to the minus 6t can't be equal to 0. So that means that the sine of 6t has to be equal to 0. So that's going to occur when t is equal to 0 or pi over 6 or pi over 3, etc. Values like that. And so we're going to have an infinite number of values, but we need to find the maximum value of the charge. All right. Now, if we look at our charge, we can rewrite this in a form that you're going to recognize. We can rewrite it in this form that we've talked about before. So we can rewrite it as minus 20 root 2 times e to the minus 6t sine of 6t plus pi over 4, the phase angle, plus 20. And the root 2 was found because we're just taking the C1 and the C2 are both 1. And so the root 2 is just the square root of 1 squared plus 1 squared. And then setting the tangent of phi equal to 1, we get the phase angle of pi over 4. All right, so what this means is that this, because of the e to the minus 6t, and the sine is going to be oscillating, then over time, the q of t is going to approach 20. So it's going to be oscillating above 20 and below 20, and then approaching 20 very quickly. And so the maximum value of the charge is actually going to be the first maximum that we come across, the first value where it's a maximum. And so if we look at, so this oscillates and approaches 20 as t goes to infinity. So it follows that the first local maximum will be the maximum value of the charge. So now if we look at q of 0, that's going to be equal to minus 20 root 2 times root 2 over 2, which just comes out to be 0. And if we look at the second critical value, the q of pi over 6, there we're going to have minus 20 root 2 e to the minus pi, and then minus root 2 over 2 plus 20. So this is going to come out to be 20 e to the minus pi plus 20, which is 20.86427. And so you can see that this number is greater And so this is going to be the first maximum, which is going to be the absolute max, because after that, the next maximum is going to be smaller, closer to 20. All right, so the absolute maximum of the charge is 20.864 coulombs rounded to the 3 decimal places. And so if we look at what we have here in WebAssign, you can see that we have the same answers for the charge and the current. And then we have the 20.864. That's going to be the maximum charge on the capacitor rounded to 3 decimal places. All right, so here is a graph of the function, and there you see like it reaching the top point. You can see it's a little bit more than 20.8 there, where you have that maximum that's occurring at the pi/6. Now, if you go out further, you see that it's just going to be oscillating, going up and down, closer and closer to 20 after that. So you're going to have extrema, but you're not going to have an extrema after that as large as this one, because it's going to get close to that asymptote. All right, so that's it on problem number 9.